And good afternoon to all of who are present for my synopsis presentation. The topic of my presentation is development of an approach for combined use of association rule and clustering methods using domain-driven mining. My name is Aarti Vaghai Deshpande and my guide is Dr. Anjali Mahajan. She is a HOD in Government Polytechnic, Nagpur. So outline of this project is this, like I am defining first background study, then problem, literature review, results, proposed architecture, and finally my paper published and the references. So when we talk about the data mining, it generates many patterns, but the problem is that we should get the meaningful patterns and the correlation from the large data sets. So discover the actionable knowledge in the real life application is a real challenge when we talk about the data mining algorithms. So problem in the data mining algorithm is that one is incapability of domain knowledge and the business regulation for which we are applying that algorithm. Then it is uncertainty, vagueness and the deficiency of the knowledge. Then a priori knowledge which is required for the algorithm. Its computational expenses is also one of the problem. And we should stop the algorithm at such pattern identification. So there are many algorithms are developed, but very few are used for the real life application. So one solution could be we can combine domain knowledge and the data mining technique together. So this is my proposed thing where I have combined the domain knowledge and the data mining algorithm using domain driven mining. That is my research area. So in my title there are three important terms. One is knowledge, domain driven and the combined approach. So what is meant by knowledge? Here I am saying the knowledge is like if we have historical data, we can get a knowledge about that data set from that historical information, and then that we can use it. Like for example, suppose in the retail shop, in the supermarket, if I want to give some promotional campaign, for that I must know that what are the different items which has been sold maximum time in last period or during festive season. So that knowledge we can use in our algorithm. Second term is domain driven. So what is meant by domain driven? Here a very few and repeatable executable algorithms are there in the real life, and many patterns are mined, but actually they are not useful for the business thing. So we have to find out such a findings or such a patterns which are actionable. That means the business people can take decision just by seeing those specific patterns. So D3M, that is a domain driven data mining, is a next generation data mining methodology which is suggested by Longbin Kao, and I have referred his paper in the IEEE transaction. So what he says that we can cater this using domain driven data mining, we can cater for a business environment, we can satisfy the business need of the people, and we can deliver such a business friendly rules so that the person who is actually going to take the decision can understand those rules. And so actually it's a paradigm shift from data center hidden pattern mining to the domain driven actionable knowledge discovery. So this is the reference which I have used. So would you like to see the paper? Now third term is, this is the domain driven concept. Now third term is the combined approach. Now what is combined approach? So combined approach is also given. I have referred this paper where the combined mining concept is given and how we can combine the different techniques or different features and different sources that is given in the paper. So what I did, I modified the architecture. I suggested my own architecture for multiple data sets, multiple features and the multiple methods. So ultimately how we can combine different data sets which are located at different locations that I have suggested with the architecture. Then how we can take the features, like suppose I have hundreds of features, how can I make a subset of that, and then how we can combine the different data mining methods together to generate more actionable rule that I suggested. So my contribution is that it's a combined domain driven data mining and combined mining approach to discover the patterns from multiple features, multiple methods and multiple sources. This is my contribution. Then I propose framework for all these three that is multiple features, methods and the sources, and then I proposed algorithm. And so I'll go one by one. I'll explain one architecture and the result, then second architecture and the result, so that we can easily understand it. So objective of research is ultimately discover and produce actionable patterns. It's an effective knowledge discovery process and incorporating the domain knowledge. So literature review. I did the literature review in 5 distinct parts. First, I did the literature review on the domain-driven knowledge discovery, how it is being used. So many papers I have given in the references. Then I have used the combined mining papers where the combined mining used. But combined mining is a little bit different concept than the collaborative mining. So I have referred those papers. Then I have seen some papers which has been used for feature selection methods and the data sources. So I have made the research gap identified through the literature review. This is my base paper, that is combined mining discovery, informative knowledge in complex data. So here is a concept of combined mining is given and experimental results are shown for the governance service data of Australia. I identified that overall combined architecture is not given in the paper. So I propose the overall architecture where we can combine all the 3 techniques together. And then clustering and association rule mining can also be combined together. That is that research gap I found out and I worked on that. Second paper is the weighted utility framework for mining association rules. So in this paper, frequency and significance of atom is considered to generate the rule. But what I identified that it can be used for multiple data sources, the same techniques, and even we can use a ranking to the atom to get more specific rule from the data set. Then third is a weighted utility framework for fourth is discovering classification from the data and multiple sources. So here classification based on data and multiple sources. It can be used to find the knowledge from the multiple databases. That gap I identified and I worked on that. So my proposed frameworks, these 4 frameworks I have proposed: multiple features combined mining, multiple methods combined mining, multiple source combined mining, and lastly domain driven combined mining. So sir, I'll explain one by one. First I am explaining multiple features combined mining, my proposed architecture, my algorithm, and then the result. And then I'll switch over to the next algorithm. See, when I talk about multiple features, I'm basically, the first step of this algorithm is generate the combined data. Now what is combined data? In the combined data, like suppose this is my business data, and I have separated my static data and transaction data from the business data. Now what is static data? Static data is like gender, marital status, age group, which generally doesn't change. And the transactional data are like items purchased during that transaction is my transactional data. Now using domain knowledge technique, I have selected only the features or the static data in which we are interested or business is interested, and I selected the transactions items in which the business is interested, and I combined the data. So from that business data, for my algorithm, I generated a subset in which the business is interested using domain knowledge technique. So we'll see that how I have used that.
Do you have an example?
Yes, I have an example.
Better to show that example because we make one superset of features.
Yes.
Okay. So is that good enough? Because unless you are having your schema or something.
Yeah, I have, sir. I just after this should I show right now, sir, or
No.
once I'll explain, I'll show you with the example actually. So once we have a combined data, like I have a subset of a data, then we can apply a multiple feature algorithm. Now here I have used a dynamic attribute feature selection algorithm, where at the runtime we can use that attribute. Like for example, just suppose I just want to generate the rule for male candidate. So, okay, so gender is one static field. So gender has female and male also. So runtime only will select male and we can generate the actionable rules for male only. Or for the age group. Like suppose during the Valentine's Day I want to generate or I want to give some offer. So I will select age group between 18 to 22. So that thing I have done using this. Then I use association rule mining, discovered pattern, and after pruning I am ultimately getting the combined rule. But here actually I am not stopping. After getting combined rule, how we can get that deliverable patterns or actionable rule? Because combined rules so we can get many. So how to get that deliverable patterns, that algorithm I have suggested. So I have used, these are the interesting subjective measures like support, confidence, then lift. So lift I have used many mota like A and B occurs together. We generally use it to give the rank. Then leverage, and additional thing that is I have suggested is lift A. Now see how we can generally do. Generally what we do, sir, when we calculate the lift, we see suppose I am getting 100 patterns. I use lift, and I use the lift which is greater than 1 so that I can find out that these are the patterns generally purchased together. But what I suggested, we can't stop here because we have one more thing, that is I have suggested lift A. What is lift A? This measures the lift of A with B as a precondition. Like in combined rule, when I talk about the combined rule, it is my demographic feature or my static feature. This is my transactional feature and this is my class label. Okay, so every combined rule should have demographic feature plus transactional feature and the class label. Okay, if I calculate the lift for this, I may get greater than 1. So this lift A, what it does, it gives the contribution of A in the rule. So if I calculate lift A of this rule, it shows me contribution of A in the rule. And when I calculate lift B of this rule, it shows the contribution of actual B in the rule. So the formula that I have suggested is lift A is equal to lift of actual lift of A tends to B and divided by lift of the transactional features to the class label. And when I talk about the lift B, is when I want to find out the contribution of transactional data, that time I calculate the lift of this and divide it by lift of demographic features in the B. So this gives me the better result. By using this lift A and AB, this I rule can be calculated. Now what is I rule? I rule is the interestingness of the rule because I am talking about the actionable rule. So I rule gives me the interestingness of the combined association rule. I rule formula is, this is I rule A tends to B is lift of A of this rule divided by lift of A tends to. And then I rule of this rule lift of B of this and this. So like what we want? We want demographic contribution or we want a transactional contribution. Accordingly we can calculate the lift. So in my work I have used I rule, that is contribution of demographic features, because I wanted to find out what are the different items that a particular class of demographic features people are accepting or going, because I want to target those customers. So I used this I rule value. So this is my proposed algorithm for multi-feature combined mining, where I first using some minimum support I calculated the rule. Then this is a pattern string checking, because I am interested only in the rule, because I am talking about the combined rule. Combined rule means demographic and the transactional features together. So I selected only those rules and then finally pattern. So this is my experimental for this. I have used Microsoft Consto BI demo.
One problem will be, how do you go on considering all pairs? A is there, B is there.
Yes, sir.
So you have to consider all the pairs.
Yes, sir. Yes.
You got the. Did you understand what I was saying? Because see, you are showing that your I rule is having the contribution of A roughly towards the appearance of B, right?
Yes.
So it is a pair. So now we may have to, for it to be valid for all the person, we have to consider all also pairs.
Yes. No, sir. What I did, I used some minimum threshold value for a support for the combined rule, and once I got those combined rules with some minimum threshold value, then I am considering only those combined rules for the further actionable. Like I tried for support 0.1, 0.2, 0.3, whatever, and at 0.4 I am getting enough number of rules for analysis, so I stopped there. And then I got suppose 15 rules, then those 15 rules I am considering for the actionable, because we have to put some filter before
So
that.
indiscriminately you are not considering each and every pair, but you are filtering the
Yes.
pairs. Fine.
Yeah, because otherwise you will get thousands of rules if we have a large data. I have given that in the experiment, sir. So I have used this Microsoft Consto BI data, which is available on Microsoft site. I have used the data for 104 customer, around 20,000 data I used, and only for 7 different products I have used. And there are 3 class labels like low, moderate and high. So every customer belongs to one of the class. So this is my customer table description, where I have used the static characteristics as a marital status and the gender. So marital status में married and single, then 2, and gender में male and female, there are 2 things are there. So this is my static data for the generation of combined data. And from this table, because there are millions of records are there in this, so I have used product subcategory only, and only for those 107 customer I filter out the data from this table to generate the combined data. So what is like this domain knowledge concept is, when I selected this subset of that, and I have used that this is my all columns which I have selected, so I can have a marital status and gender as a static feature for my further implementation, and I selected the product subcategory only. So runtime only I have given the provision, so whatever is our interest we can select that. After that again there is a possibility, like marital status may there are married and single. Okay, if I am only interested in the married, I will select only that subset. So we can filter out like this. Like there are 7 items I have selected, but if suppose I want to produce the offer only for television and VCD, so I will select only television and VCD and married and only female. So reduction of the data happens at the runtime only, and I can get a combined data where I have the static features and the transactional features together, so that only I can able to generate the combined rules. So first I use association rule mining with the support 0.05 and confidence. So I tried for many supports, and this is ultimately I stopped here. I have given in the thesis that with the graph. So I got 56 rules from the transactional data and 19 rules from the demographic. See, if you see the formula, every time we need, that is a lift of transactional data to the class level, and we need the lift of demographic data with the class level. So separately we have to generate the rule for only transactional data and only demographic data also to find out the iRule value. So I got these are the rules generated from the transactional data, and these are the rules generated from the demographic data. Then I got these are the combined rule. Now in this combined rule, after generating this algorithm for the combined rule, so what combined rule says, every rule left hand side should have demographic feature and the transactional feature, and right hand side should be the class label. So I got this rule. This is a subset of rules. Okay,
Please
and
explain rule number 9.
Rule number 9. So this is Bluetooth headphone is a transactional item. Okay, and this MP4 and MP3 is a transactional item. So I have 2 transactional items. This is a Bluetooth headphone and MP4. This I call it as a B. Okay, and this is a married is my demographic or a static feature. So I call it as a. So this rule is A and B tends to T. So T is my class label. So all those combined rules are having demographic and the static feature with the right hand side as a class label. So
Now the point is that although support is very less,
yes.
many rules support is very less, but there isn't so much difference in it. The general point to think about is that in many of the cases support is very less
Yes.
for the rule.
Yes.
However, there isn't so much of difference in the lift.
Yes. So much difference happens. That's why I suggested sir iRule. It gives me ki if I am taking, like suppose these are the rule generated. So I can say ki all rule ka left is above 1. So I cannot consider but all rule as a final actionable rule, because just we cannot rely on this, because with the support that the lift increases. It's less though it increases. So for that, then what I did, once I got this subset, I suggested the iRule feature. So I used this iRule calculation. So for every rule, I separated the demographic feature. This is my demographic feature. This is my transactional feature. This is my class label. Okay. This is the lift of A tends to C. That means the demographic features. This is demographic features to the low is this lift, and this is transactional to the low is this lift. Then I use that lift A and lift B formula. I got this 2 lift, and ultimately finally I am calculating iRule value. Now you can observe that I am getting the variations in the iRule value. So I'll just explain you how we can see. You can find from this graph, this first 4 rules, though the lift is high, but the iRule value is less. Okay, so as the I rule value is, we cannot consider that as a actionable. So why we cannot consider this as actionable? Like suppose this is my this is one example which I have given. This is rule number 11. Rule number 11 is giving me the highest I rule value. Okay, but if I find the lift of this rule, this is also highest 2.26. So this is possible. Many times if I have a highest rule value, I may get a rule value. But second example, I will show you that rule lift is high, but the I rule value is lowest. Okay, so this is actual lift value and this is my calculated I rule. So what it suggests that I calculated for lift of female, then I calculated for lift of transactional data, and then ultimately the I rule value. So what this rule suggests that as the lift of A is 1.15, which indicates that under the transactional atom, Bluetooth headphone and home theater system, demographic features female become positively associated with the class moderate, because lift of A is higher than the lift of A tends to C. See, lift of A is higher than the lift of A tends to C. So what it suggests that under this influence, that demographic feature is highly related with this. Similarly, B tends to C is less than the lift of B. That is, lift of B tends to C is also this is also less than this. So what it suggests that in both the way it is possible. It says that is transactional atom, Bluetooth headphone, home theater system, to the occurrence of a class moderate increases with the demographic feature female. So ultimately we can make a statement that female belonging to moderate class are more interested in Bluetooth headphone and home theater system. So this we can find out through I rule value, because it is giving me the highest I rule value. But in the second example, sir, you can observe that in rule number 1, I am getting lowest I rule value, that is 0.66. So if I only consider the lift, so lift of this rule is 1.36. This overall combined rule is 1.36. So we can say that positively correlated. But when we calculated that lift A and B, so you can observe that lift of A is less than lift of A tends to C. That means they are not actually not giving more impact on that rule. And similarly, lift of B is also less than lift of B tends to C. So as both lifts are less, I am getting I rule value is also less. So as this I rule value is not above 1, I cannot consider this as a final actionable pattern, because if I am getting thousands of patterns, my aim is to filter out and give the more rules which can consider as a specific rule or an actionable rule. So that summarization of MFCM is that contribution of demographic features and the transactional atoms together is very important to discover the combined rule. Only lift cannot find the interestingness of the rule. So I rule is an interestingness measures which helps to find out the final actionable combined rules. And use of this application is like this knowledge helps in buying patterns of a customer with different demographic features. We can reduce the cost of promotional campaign, and even for a particular product specific rules can be generated. Then this is my second architecture I propose for multiple method combined mining. So for the multiple method, this was multiple features and this is multiple method. So this work is limited to the serial multiple method combined. Serial means I have used multiple methods. Like I have used in my title I have written that association and clustering. So I have used the combination of association and clustering in a serial manner. There are I have seen the paper they have used parallelly or in a closed loop format, but my limitation is only in the serial way. So proposed method combines only clustering and the association, and I have used agglomerative hierarchical clustering and k-means, and association may I have used the a priori algorithm. So this is the framework which is saying that this is my data set. First of all, we must have the knowledge about the domain. So what should be the result of my algorithm, and accordingly I can combine the different types of algorithm together. I can combine n number of algorithm. So here first method 1 का result will be the input for the text and plus the data set. Similarly we can go and ultimately we can achieve that final pattern P. So this is the framework for only clustering and the association. So how I work, I use the clustering on the data set. Then for every cluster I have used pattern mining, association rule mining, and finally I have used that analysis or a pattern merger algorithm to generate the actionable rules. This is my proposed algorithm for that. So should I explain this? This is one. Second technique is, then this is one that we have generated and local pattern based we can do. Then I suggested one more, that is serial multi-method combined mining based on weights of atom. So weights of an atom is actually used when the demographic features is not there. Like suppose I want to make a clusters of people, so I need a suppose demographic feature. So based on demographic features I can make the cluster of people, and for those cluster I can find out the association rule and can target only those cluster. But suppose when we work on the real life application, where if we don't have a demographic information of the customer, like customer is going in the supermarket and buying some atom, so on what basis we can do? So I have suggested this weight method. Like this is my transactional data set for 4 atom A, B, C, D, and these are the 8 transactions. Now I have used the domain knowledge of the data set D. So I have used 4 atoms for these 4 atoms. What is the stock of a quantity which is available in the database? What is the support of that items? That means how many people has purchased that atom, and profit in percentage. This is just given the example, sir. We can decide we can consider the criteria in which we are interested. Like I am interested in profit or cost or expiry time or a stock. So we can consider that way criteria. Now once we have this criteria, then we can find out, we have to normalize this for every item. This is stock, support, and profit percentage. So stock we generally count in terms of quantity. This we support we count in terms of number of times it happens, and this we count in terms of rupees or dollars. So for that we have to normalize this. So I have used min-max normalization to normalize all the values, and all are now between the range of 0 to 1. Then after that I have considered the weightage for every criteria. Like for the stock I have used 0.2, for support I have used 0.2, and this is for 0.2. Suppose I have 5 criteria. I have to select weight in such a way so that sum of all weights should be equal to 1. Okay. Now why I have considered here 0.6? Because suppose my domain needs to clear the stock which is available with me. So I given higher weight. Suppose I want to earn more profit, so I may shift it to the profit or expiry in days. So it depends on the domain knowledge again, where you want to use the maximum weight. Then using this normalized matrix and this weighted matrix, calculate the weight for every atom using this formula. So these are the weights for every atom. Now these weights, it depends on all these 3 criteria value and the weightage given. So it doesn't matter if A is giving me the highest profit, so I'll get the highest weight. So accordingly every atom ke liye that the weight is calculated. Now after calculating the weight, this transactional data is replaced with the weight value of those atoms. So like in the first transaction, every value is replaced with the weight. Find out the sum of all weights value. Now every transaction value is equivalent to one weight value. So I am actually giving weight to each transaction to cluster the transaction. So every transaction is having one weight value. Now suppose I have 20,000 transactions, I have 20,000 weights. Because demographic data is missing over here. So I implemented that for a data set experiment. I'll show you that time that how I use clustering.
Maybe you can speed up a bit.
Okay. Now the first method, multiple methods which I have used for credit card data. I have used these demographic features and I have converted that data in this format. I used the hierarchical agglomerative algorithm and I divided into 2 clusters. So when I divided into the clustering based on the demographic features, we found that the cluster winner are having more people with the good class and maximum male people, and here employment greater than 7 years and having critical account, and that other people are having the different. So this is the with the demographic features I am getting the different type of cluster. Once I got this different type of cluster, I tried for different support value, and ultimately I set to the value 0.2 as a support. Then for the cluster 1, I use rule mining algorithm and I got these rules. Here the bad class rules were missing. I was not able to get the bad rules for the cluster 1, but when I use it for cluster 2, I am getting good and bad rule both. Then I use the same algorithm for combined data, that is without clustering, the overall data, and then I compare this all rules with this. So I found that only these two rules which are common in all the three. This is the cluster 1 rule, cluster 2 rule, and this is all credit rule. So I am getting only these two common rules, and many rules which I am getting which are not there in the other cluster or the integrated data. So summarization is like the bad class are missing in the cluster 1. So if we want to target the bad class customer, we have to target the cluster 2 people only, and we can define the rule. Then next is the CES data, experimental result for CES data. This also consumer expenditure data. I worked for the similar algorithm for this CES data. So here I used 3 clusters, sir, but ultimately I observed that, see, number of cluster, how to decide is the cutting of the tree at a certain level. So here I observed that cluster 2 and cluster 3 people are buying similar pattern. So ultimately after this also we can combine the clusters. Then this is for experimental result for this Constro BI demo data, where I have used these demographic features. 3-4 I'll show you this weighted one.
It is better if you are having some other data or
I
some
said groceries data set I have.
comparison against other algorithm.
Sir, I have compared it with the classical rule mining algorithm, Applied algorithm. I showed you, no, sir. So this is my comparison. When I worked with the cluster data and
See, the thing is that when you compare, you should compare against the right comparison. Okay, you cannot compare some old man and a Pehlwan. You compare Pehlwan is always better. So, suppose you have invented your method now, you should try to compare it against a recent method, 2012, 2013 approach. You should compare it against that, not against some very old approach. Okay, because that is against contemporary approaches, you must show that your work is better. Yeah?
so this is a groceries data set. So this groceries data set are taken from our data set. The demographic feature is totally missing. Now that weight algorithm which I have just explained you, I used here for that groceries data. So what I did, I converted that data into the basket format and I calculated the weight of every transaction for this algorithm. So finally, and then I use this domain knowledge like count, stock, expiry in days and the profit. These values I generated for each and every item. There were around 169 items were there. So for all those items I generated this count, stock, expiry dates and profit, and then I find out then normalize this data, and given the weightage I have given the expiry days highest weightage because in my domain I want to clear the items which are about to expire, and then I got the weight for every item. Then after calculating the weight for every item, that complete data set is converted into weighted and the weight for a transaction is calculated. After calculating the weight for the transaction, for this weight value, I used the algorithm, a clustering algorithm, and I got 2 clusters separated based on the weight. Once I got this separation based on the weight, I used association mining algorithm. Now sir, when I use association mining algorithm, I use that algorithm for cluster 1, cluster 2, and this is my integrated data, that is without using weight. It's a overall data where I have not used weight, only that association rule mining is applied. So only that yellow colored rules which are common I am getting, but in many cases in cluster 1 we are getting this 3 rules which is having the highest support. So we can sell this other vegetables and the whole meals together if the weight of the basket is high in cluster 2 people, while cluster 1 people are not buying those items with the high weight. So observation is that if we have such type of a technique, we can give the here we can see that cluster 2 people are like tropical fruits and other vegetables, and cluster 1 people are interested maximum in soya oil. So what we can do, sir, at the time of a billing only we can generate such offer to the people who are buying the items based on the weight of the basket of that person, because it is very new idea. When we get an offer, it is displayed and we are not getting instant offer at the time of a billing. If to the customer based on the basket value we are giving something free or something 50% discount, so he will be happy and we can retain the customer also. Then last is my multiple source combined mining. In multiple source combined mining,
quick summary.
this quick summary, I'll show this is a different data sets. Then I have suggested again 2 algorithms. One is a local pattern mining and another is a weighted pattern mining. So from this data sources, every data source we have used this association rule mining, generate the pattern, and instead of transporting the transactional data to the server side, transport the patterns which are generated from the local side to the server side. Because suppose like for example Big Bazaar has an outlet in 10 location and I want to generate one common offer for the Big Bazaar in all 10 location. So I should have the knowledge about the buying patterns of the people. So instead of transporting the transactional data, you generate patterns over there and transport that pattern to the server side. Once the patterns are there on the server side, there should be a pattern merger algorithm which I suggested so that we can get a actionable rules for that. I'll show you the results. For this synthetic data I used this is the data which is generated for these items, and then a priori is used for 10% support and 40% this thing. Now these are the patterns. I have taken top 10 patterns from source 1 and source 2. We can go for n number of sources. Now from that source 1 and source 2, these are the patterns which I got. So you will find that blue colored marks are only common pattern. Suppose I have 10 sites and I am getting some 4 patterns common in all the 10 sites. I consider that as a final actionable because all people are interested. Now what we should do with the remaining one? So what I did, sir, like this remaining one, I have considered first 2 are the common blue one. Then the butter is there. So I targeted the butter and I observed that we can find out that whether the butter, at the left hand side of the rule, whether it is purchased in any one of the side. So the butter is not there on the left hand side of this. So you just skip that rule. Then you go for the next one, that is jam. So we observe that this jam is purchased in site 1 also and site 2 also. But here the people are buying jam and butter together. Here jam and bucket combination is there. So these are 2 different rules. Here they are interested in jam and butter, and here they are interested in jam and bucket. Like this we have to go for all the site rule, and then ultimately we have to combine them. So what is the next step? This is a pattern merger algorithm. Like I got jam, this is source 1 and this is source 2, source 3, source 4, like this. So jam is purchased from in the source 1 left hand side but with the butter, and the support is this much. Jam is purchased on the source 2 with the bucket and the support is like this. So like this, suppose I got this 3 rules. Then after getting this rule, you just take all the rules in the actionable pattern. Now once I am saying actionable pattern, though those rules are not in the top 10 but that are above the support. Like here we can find out jam and butter is having 16.45 support in source 1 and 16.5 in the support 2. As we have considered top 10, we are missing that. But those rules are there on my server side. So as it is purchased on the both side with the above support and not getting, so I will consider that. Here, but we observe that this juice and bread, though I am getting, it is not there, so we will not consider. But it is not like the case. Suppose there are 5 sites, I will consider some threshold and I will consider like 3 sites में at least.
Please conclude.
Sir, this is second ranking algorithm.
That's okay.
So this is overall architecture which I said. We can combine all the techniques together, multiple features. This is my
That's okay.
suppose.
That is anyway, you have explained the component approaches, so it is a
Yes.
combination of the component approaches so
Yes.
that I can understand.
So this is the conclusion that we can use it in the real life, because when we see on the Amazon, we get suppose we are buying one atom, we get hundreds of atoms on the offer, but they are not targeting that customer particularly. Okay, if you have purchased this thing, this is a free or on 10%. Here my target is you should be very specific. Like when we give the rank to the atoms, we know that top 5 atoms we have to sell anyhow. They are about to expire with high profit or whatever. So instead of showing all those 10 atoms and to get the customer confused, we can target the customer with particular 1 or 2 atom, or we can give free, so we can retain the customer like this. Even in the supermarket also, sir, we can use this technique where at the time of a billing, we can give him one Maggie packet free. It's about to expire. Because when we, means this is just criteria I am considering, because we observed, sir, generally the offer items are about to expire only, if you see that date, or with the profit high. So scope of the future work is that we can do the same thing for negative pattern mining also we can use, because which also play a very crucial role, and we can design a tool for that. These are my papers published, and these are the references.
Yeah, what you should do is actually you should try to send some research papers to say the IEEE transactions on knowledge and data engineering.
Yes.
So if you send to some publication like that, then only you will know that what is really the true worth of your.
Sir, I have sent one paper. I am waiting for the review. That overall my research work I combine together and send to Springer, sir. So that review takes a lot of time.
More than that, transactions on data and knowledge engineering. Each submission there, although it will take time, they will give
Yes.
5 or 6 reviews, and it will be very complex from all the angles and all the.
Sir, they said me to work on real time. Then I talked to the Big Bazaar and DMart, but they are not ready to give me the data.
Nobody will give
So
you
I
that.
tried for 1 year, sir.
No
No one is giving.
nobody will give you that kind of
Yeah.
data. No. There are the known data sets which are there, which you can use and compare, because all the time, say like this KD nuggets and those kind of data is there, or even if you can go to ML repository, those
Yes.
kind of data are also there.
Sir, I tried that only. My
Okay.
Microsoft
And,
wala data is good, sir.
See, what I am seeing is that in some way your approach is something like a demonstrative reduction.
Yes.
It is some kind of a demonstrative,
Yes.
because what happens is that you're, let us say, you're constructing something like a super table. The
Yes.
super table is that where it is having all your the two types, that is temporal and related, and the static and those kind of things.
Yes, exactly.
And then there, so maybe that some aspects of those tables may some columns or some rows may be sparse or something like that. But then from that you are trying to dig out the more solid ones. So in some sense it is kind of, so if you want to say that, you can also see this as a problem of demonstrative reduction, and you can try to compare your work against those demonstrative reduction approaches and show that how yours is effective or what is the difference and things.
Sir, I tried with that wrapper method and all also, sir. The same my algorithm. I wrote that in the paper, but they said real time data, so I'm looking for that real time data and no one is giving me. So I'm using that only, sir. Thank you very much, sir.